Hello everyone. Let's discuss the numericals on Van't Hoff factor I in this module of the chapter Solution and Colligative Property. The question is 19.5 grams of monofluoroacetic acid was dissolved in 0.5 kg of water. The freezing point of the solution was observed to be -1 degree Celsius. Calculate the Van't Hoff factor, degree of dissociation and dissociation constant of acid. Kf is 1.86 Kelvin kg mole inverse. Given the solvent is water and the solute is monofluoroacetic acid, its molar mass is 78 gram mole inverse and the formula is CH2FCOOH. Now the first thing given is 19.5 gram, which is nothing but W2. The second thing which is given is 0.5 kg of water, which is nothing but W1, which is 0.5 kg. And they have given the freezing point of the solution, that is -1 degree Celsius, that is nothing but TF observed, which is -1 degree Celsius. Also they have given the value of Kf, which is 1.86 Kelvin kg mole inverse. Now they are asking to calculate one Van't Hoff factor, that is I. Second one is degree of dissociation, that is alpha, and the third one is that is dissociation constant of the acid, that is Ka. With this data, let us write the formula first. The formula for I will be in terms of depression of freezing point, because TF observed value is given in the data. So I will be delta TF observed upon delta TF theoretical. Alpha will be I minus 1 upon n dash minus 1 and K will be m alpha square upon 1 minus alpha. So we know what is given, we know what is a formula. Let us begin with the solution. In order to find I first, I require delta TF observed and delta TF theoretical. So to find delta TF theoretical first, I require Kf and m. Kf is given as 1.86. We'll need to first find small m. So small m will be equal to W2 upon MW2 into W1. We have the values of MW2 and W1. So we substitute that. It's 19.5 upon 78 into 0.5. And the value of this will be equal to 0.5. So now we know what exactly is the molality. So now we'll find first of all delta TF theoretical, which is given by the formula Kf into small m. That is 1.86 into 0.5, which is equal to 0.93 Kelvin. Once we know what exactly is delta TF theoretical, let us find delta TF observed, given by the formula T naught F minus TF of the observed. T naught F is 0 minus of -1, that is nothing but 1 degree Celsius, or it can be written as 1 Kelvin. So now we know the value of small m, delta TF theoretical, and also we know delta TF observed. So we can easily calculate the value of I. I is given by the formula delta TF observed upon delta TF theoretical, that is as good as writing 1 upon 0.93, which is equal to 1.075. That's the value of I. So by far we know what is small m, what is delta TF theoretical, what is delta TF observed, and now we know I, that is 1.075. That was the first thing which we need to calculate. The second thing is alpha, and the formula for alpha is I minus 1 upon it is n dash minus 1. So we don't know the value of n dash, so we'll write the dissociation equation of the monofluoroacetic acid, which will dissociate as CH2FCO minus and H plus. From here I come to know that n dash will be nothing but the addition or the sum of the moles of the product, that is nothing but x plus y, where x is 1 and y is also 1. So n dash has to be 2 over here. Substituting the values in the equation, what do we get? Alpha is equals to 1.075 minus 1 upon 2 minus 1, that is nothing but 0.075 upon 1, that is nothing but 0.075. So we got the value of alpha by far, correct? Now we'll move towards the value of Ka. Ka is given by the formula m alpha square upon 1 minus alpha. For those who are wondering how do we get this formula as m alpha square upon 1 minus alpha, it's by this thing. So monofluoroacetic acid dissociation gives me CH2FCO minus and H plus. Let us first find initial moles. For the reactant, that is monofluoroacetic acid, it is going to be m and the product is going to be 0, 0. And equilibrium moles of the product, that is CH2FCO minus, will be M alpha, that of H plus also has to be M alpha, and that of the reactant, that is CH2FCO minus, has to be M minus of M alpha. So now if I take the help of equilibrium and if I just write the equilibrium constant K, which will be nothing but the concentration of the product upon the concentration of the reactant, that is concentration of CH2FCO minus multiplied by concentration of H plus upon its concentration of CH2FCOOH. Substituting the values, we get M alpha multiplied by M alpha upon M minus of M alpha. Taking that equation that K is equals to M alpha multiplied by M alpha upon M minus M alpha, let us remove M common from the denominator. So what do we get? M alpha, that is M square alpha square upon M bracket 1 minus alpha. So ultimately we get that equation M alpha square upon 1 minus alpha. Let us substitute the values. M is 0.5 into alpha is 0.075 the whole square upon 1 minus 0.075, and the subtraction value gives me 0.925. This on further solving will give me an answer like 0.00304, which can also be written as 3.04 into 10 to the power minus 3. That is how we solve such type of questions, especially with respect to dissociation constant of the acid. That's all we have for this particular module. Thank you so much.